Hey everybody, I'm Jamie Beard. I'm the Executive Director of the Geothermal Entrepreneurship Organization at the University of Texas at Austin. And oh my God, this is going to be an awesome competition. You are at the Pivot 2021 Geothermal New Venture Competition, the first one that we've ever held, and it's going to be insanely cool. So what we did here and why we're doing this competition today is we decided to do an experiment. We noticed a couple of years ago that there was this huge flourish of activities, all of these startups joining the space in geothermal. And we figured, hell, why don't we cast a wide net? Let's see what we see. Let's ask startups to pitch and let's build a platform and make it, invite them to come and we'll see what we get. And we were absolutely ecstatic with what happened. We had dozens of startups from around the world internationally apply to pitch at the semifinals, the Pivot semifinals, which happened in June. We had 10 startups pitch in the semifinals, and today you will see the top 4 finalists that came out of the semifinal round, all amazing companies. You'll hear more about the semifinal round later in a little highlight reel that we'll show you, so you get to see all 10 semifinalists later. So what they'll do, the four startups are going to pitch to you, the audience, of course, but they're also going to pitch to an insanely awesome duo of judges, which I'm not going to hesitate to get in here because, oh my God. Okay, let's go. We have our judges, Chris Anderson of TED and Richard Branson of Virgin. Hello, guys.
Hi, how are you doing?
Welcome to Geothermal. Oh my God. So anyway, nice to see you all. Honored to have you. Thank you very much for being present here and listening to our startups. So here's the run of show. We're going to have 4 startups pitching to you, one after the other. They get 3 minutes for their pitch. They get 12 minutes for Q&A. And then we will wrap back around after all the pitches to do a feedback session with the both of you. Now, audience, watch the pitches because you'll have a chance at the end to vote for the winning startup through an audience choice poll. So stay tuned. Okay, so Richard and Chris, you ready? Ready to go? Let's launch. Okay, we'll see you.
Okay, what goes Mach 5 and disrupts 3 major industries and makes geothermal drilling anywhere possible? It's this projectile and millions more like it. Today, we're talking about hypersciences. Our hypersonic robotic accelerators solve world-class problems. Ultimately, we make whole at Mach 5, disrupting geothermal, energy, drilling, mining and tunneling, and air-breathing hypersonics. My name is Mark Russell. I'm the CEO and I'm the founder of Hypersciences. I've got a master's degree from Stanford in aeroastro engineering. I've led some world-class projects in both aerospace engineering, including a crew capsule development and a VTOL lander, as well as drilled some of the deepest holes in North America. I'm a hybrid, creating a company that uses aerospace technology to merge with underground. We have experts in hypersonics all the way to oil and gas drilling from Houston. The problem today is energy poverty and climate change are interlocked. We're literally burning our forests down just to heat water and get a standard of living that's compatible with the first world. And so we need a renewable energy source that's baseload power. Today, we live on a planet that is a giant nuclear reactor. What we need is low-cost drilling to access, like a heat exchanger, a closed-loop system that goes down to 5 kilometers or deeper, long, large area holes to bring that energy back to the surface. Today's drilling technology can reach the depths. It's just too expensive. The amount of energy is minuscule for bringing it all the way from those massive surface machines to the bottom. And wind and solar, it's intermittent, it's expensive, and the actual installed baseload cost is just not able to sustain. The solution for drilling was showed to us by DARPA in the 1970s. These concrete projectiles to fire at Mach 5 using expensive industrial grade propellants to tunnel literally 5 times faster with a howitzer than any type of solution before. It sounds crazy, but what we did at Hyperscience is we took chemical energy, used really simple hydrogen, biodiesel, natural gas. And what we do is we fire these projectiles at hypersonic speeds to break rock in the world's hardest granite and deepest rock in order to turn it into kinetic energy, which definitively turns it into broken rock. We are working with the world's largest companies today to gain 10x to 20x improvements, Shell, major oil, and major mining. What we do is drill case and caseless with tunneling and drilling a larger hole with our technology. Any rock, any type, it's not fracking, it's directed energy like a heavy laser. Our goal is to be an owner partner, tunneling over 1.5 miles a week for under 3 million a megawatt installed. We have a Series B we're doing. It's a crowd-funded Reg A and a Reg D that you can participate. We're looking for thought leaders in geothermal space, the use of proceeds to build the tools, lease the land, make the holes, and complete our hypersonic R&D. We're one of the world's largest crowd-funded back in 2019, and we have a crowd that wants to support geothermal anywhere. So I'm Mark Russell, and happy to take your questions.
Wow. Yeah, that's I just managed to keep up with you. Incredible. Is there any environmental concerns about releasing anything like methane or anything into the Earth's atmosphere with geothermal?
Yeah, no, it's a great question. We've worked with Shell, we've worked with other majors that actually do drill for those resources. In fact, they said, look, we don't know a lot about geothermal, but if you teach us how to drill fast, you'll learn what you need for geothermal. And so we've actually worked in compliance with their health and safety and shown that we can only drill in hot, dry rock, which is where we're going with deep geothermal. You're going to hear some other speeches today about getting there with these big heat exchangers. But we can drill with some of the most complex formations with our technology without any risk to the crew and without risk to the environment. We don't create seismic events. We're not fracking, but we're like a focused heavy laser beam, just pulverizing the rock right in front of us, game changing how fast you can get there, which means your cost can get compatible with geothermal anywhere. You don't have a solution with geothermal drilling anywhere unless you do it totally differently than rotational.
Would you do it in the sea?
We would do it definitely we've looked at desal plants as an opportunity for both using the thermal and the potential to generate electricity. So yeah, I mean, how much of the population around the world is along the sea coastline? So absolutely. What you really need is the hard rock that's hot. And we would start with, I mean, it could be as places like Hawaii, where you're near the surface, hot rock, and grow the technology into the deeper applications. So.
Give me a better mental picture of what's going on here, because I love the video of the shell blasted against the concrete wall, and
Sure.
Totally get how that's powerful. But I mean, you're talking about drilling like a couple miles under the Earth's surface through.
Yeah.
How can that possibly work? Like if you fire one of these shells, it smashes the rock in front of it. What happens to the shell? What happens? Isn't it going to then block the next shell? Give me a picture of how this actually works and how you get rid of one shell and the process continues.
So I'm holding up one of my projectiles. Hopefully it'll show. The projectile is actually made out of concrete and plastic in different form factors. Some are shaped with our novel RAM accelerator shape. It's literally like a jet engine in a tube, but the projectiles themselves are made out of erodible material. So when they hit, both the rock and the projectile both pulverize. We literally are on phase 2 testing in field trials with our technology, and everything turns to dust at Mach 5. And the ability to transfer that kinetic energy down hole, we actually push the projectiles. Again, not like fracking, but there's technologies, plugs, darts, balls that have been pumped down endlessly in oil and gas wells. We use similar technology where we actually bring it right to the bottom, and our hypercore units that you'll see right here are actually at the bottom of the hole. So yes, we are flying projectiles at supersonic and hypersonic speeds over about a ½ inch of water.
Okay, and how many a minute? Like, is this like a machine gun?
It is firing at about 5 to 10 seconds per shot. Yes. So yep, it's all about shot rate and making sure you're keeping up with any of the material movement systems. But it operates just like a conventional drilling system, except you're going just orders of magnitude faster.
But someone
sorry.
Go on, Richard.
No, I just want to. Have you actually achieved Mach 5 yet?
Yes, absolutely, and repetitively, both in our labs and out in the field.
And is it working? I mean, have you done?
It's amazing. You are making topsoil at that speed, and it's very much constrained. So what we were amazed with, Richard, was when you fire, you're in what's called a hydroelastic event. Both the rock and the projectile both see themselves as liquids, and that's the magic, is that you actually tear and pulverize just that localized section, and the rest of the hole is in actually quite beautiful shape. We were surprised at how perfectly and intact, so you don't end up with this fracturing that other oil and gas technologies.
And what's the deepest you've been so far?
So we've tested at equivalent, we'll call it what they call perforation charge testing at the equivalent of 2 kilometers deep. In our actual mines, we're actually in extremely hard rock, but nearer the surface. So our phase 2 is about developing and testing a 1 kilometer drill for production for our partner.
But isn't the temperature down as you get deeper for actual geothermal applications possibly going to change the physics? Are you like when you get down to like 200 degrees, are you sure that that doesn't lead to something very different happening? Because I'm concerned that some people looking at this are going to say, this is scary, or you're pumping this huge energy down that depth. How can you be sure this isn't going to do something really weird down there?
Yeah, no, it's a great question. What we aren't trying to do is get past the crust, right? We're not trying to go into the liquid mantle. So we do core the rock. We have samples all the way, to the targets that are multi-kilometer. I personally have drilled past 3.5 kilometers and led, like I said, some of the deepest diamond drill core holing in North America for a mineral exploration program for clean minerals. But yeah, that rock is super hard down there. Actually, it gets stronger. The cool thing about our technology is the dynamic pressure when that projectile hits is 10 to 100 times that compressive strength of the rock. So the temperature is probably a 3rd order effect. The rock strength is a 2nd order. So we're pretty sure, and we've done an awful lot of testing, but we're going to go deeper and we're going to check it, in the real field conditions. We use it for tunneling fast as well. So not only do we drill.
And you believe that this technology is fundamentally lower cost than, for example, than traditional drilling, even specialized drilling, specially designed for high temperature.
It is so low cost, particularly. So we've worked with BP, we've worked with Shell, we've looked at all their cost models. They've gone back and audited us. They're certain it's lower cost, or they wouldn't have funded. And so is this major mining company that's very committed to the clean environment. Yeah, not only is the cost, but drilling and blasting equivalent. This is the key where I'm both an aerospace engineer. My whole family's in the publicly traded mining sector. So what we did is we created a tool that you could make bigger holes with. And this is the key for the micro tunneling for geothermal. Rather than just grinding away the rock, we actually make a little bit bigger hole, which you need for the surface area for deep energy, but you're more like tunneling it. So you're opening the area up, your rock breaking gets another 10 times more efficient. So yes, the cost demonstrated by DARPA was if they could get rid of the cost of the propellant, you could get a 30 to 50% reduction in equivalent drill and blast. So yeah, our models are very solid, and I'm happy to dive deep with you as the other majors have. We're pretty excited. We've actually, we go out. This is our 0.5 meter tunnel. We did it under contract and showed. In fact, I just gave a presentation in Las Vegas. For small projectiles, here's your rubble. For the larger projectiles, and then we grind it up at the bottom and bring it right back to the surface.
So is this, do you see this as mining, or do you see this as reducing the amount of carbon output by taking away from windmills and solar and dirty fuels?
Well, I think that one of the key pillars of hyperscience is we started with, we can deliver geothermal anywhere by delivering a better drill. What we've learned, Richard, is small is not ideal for geothermal anywhere. You need a big heat exchanger, and therefore you should micro tunnel rather than try and do 100 to 300 millimeter holes. You should be doing 500 millimeter holes or 0.5 meter to get that heat exchange. So I call it heat mining. Honestly, it's a bigger holes, but it's all the same. You're trying to.
If this ends up working, how much carbon do you think you could save over every decade? Carbon output.
Well, we believe we could reduce our dependence on oil and gas, period. It's anywhere. So, you know, the total carbon output of our current use of hydrocarbons can be supplanted by ourselves with deep energy. We're a nuclear plant. We're sitting on this earth. We're only, quote, smart enough to drill the thickness of our thumbnail right now. This allows you to drill twice the thickness at about 1/10 the cost. And that's the key. You cannot get it.
How far are you, Mark, from persuading your first customer to actually pay you something?
We're 3 customers in.
Okay, so you're
multi-year, multi-tens of millions of dollars contracts for the drills that bring us clean minerals. We actually have upstream owned project in Asia where we're delivering solutions for mineral, and the governments there want geothermal as well.
How do you avoid, if you're going diamond mining or gold mining, destroying the gold in the mine in the first place, the gold or the?
Oh, you know, that's the thing about the gold mining or platinum mining or whatever, is that so much of it is just bound up in the rock for a 1-ton rock, maybe, you know, a fraction of a percent. So what we do is we intelligently mine out the vein with hypersonic, and then we separate that material in 2 different streams. So we're actually more efficient if you're doing vein mining. If you're doing bulk mining underground, you know, all the big open pits are gone, and we don't need that anymore. What you need for clean minerals is to go underground, and this technology is not only good for geothermal, but it's great for clean mining as well.
Well, as far as I'm concerned, congratulations. It sounds ridiculously exciting.
It is. Going Mach 5 every single day, it's hyper incremental, and we love it.
And congratulations. I think you had some involvement with Blue Origin, so many congratulations on that.
Well,
as well, so.
I am so excited for you and your journey. I am an astronaut wannabe, and I do intend to fly. So thank you so much. Yeah, I did design the crew capsule at the beginning of the company and their VTOL lander. So my whole family did mining. So aerospace guy goes underground to leave the planet again.
Brilliant. A real delight to talk to you. Thank you very much.
Well, thank you, Richard. Thank you, Chris. We really appreciate it. All right. Cheers.
Hi, I'm John Clegg. I'm CTO of Hefe Energy Technology. I've got 30 years developing high temperature drilling solutions for the oil and gas industry, and our core team has got more than a century of similar experience between us. Geothermal gives us the opportunity to push our skills into the energy transition, and we founded Hefe to push temperature capabilities into directional drilling so that geothermal could supply clean energy to the world. So enhanced and closed loop geothermal systems for hot, dry rock are a new and rapidly developing and scalable geothermal installation. They'll work anywhere, and they can increase power by a factor of up to 10 when compared with conventional installations. They've got a lot of funding traction, and there's a huge amount of buzz and excitement about them, but they're technically challenging to drill. For some of these designs, accurate well positioning miles below the surface, but sometimes requiring accuracy within inches, is required for them to succeed. Now, this capability already exists in oil and gas where temperatures are lower, but the technologies used there don't meet the temperatures required to make geothermal economically interesting. The Hefe team, therefore, is going to redesign and repurpose oil and gas directional drilling technology from the ground up and specifically for geothermal, initially targeting a temperature limit of 225 Celsius, which we think is a near-term sweet spot for hot, dry rock system development. Our timeline's aggressive. We're going to de-risk the electronics and the sensors, which are the bits that are most susceptible to temperature, through some pretty brutal stress testing, and get ourselves a prototype in 12 months and a working measurement tool that's going to give us real data from a real geothermal well in 24 months. The capability to steer the drill bit is much lower risk because that's more a mechanical system, so that within 36 months we'll have that, and then we'll have the world's first 225 Celsius directional drilling tool for geothermal energy development. Now, for geothermal, hotter is better, and hence our temperature requirement. And we're going to leverage cross-disciplinary partnerships, including technology from space exploration. And one of the things we aim to do is to work with the team at JPL, who are going to create the Venus lander. there's an enormous amount of cross-disciplinary potential between geothermal and space because of temperature, and our team's going to leverage that in order to ensure our success. So why should you care about this? Well, we can leverage decades of oil and gas innovation and existing technology to unleash geothermal development globally. We're not going to break the laws of physics. And in the best tradition of innovation, we're going to try and repurpose existing stuff that already exists in different industries to give us faster, more precise drilling, lower failure rates, new capabilities, and critically drive down the cost of geothermal wells to enable an entirely new areas of development for them. We want to have a green drilling boom, but first the world needs tools to make that happen, starting with the picks and the shovels and moving on to add things like software and production optimization. And we've got the team to create those tools. And with that, I'll say thanks for your attention, and I'm happy to take all of your questions.
Thanks, John. I mean, obviously you've had a tremendous track record, 30 years of track record, but you're really talking here about an untested. You believe it'll happen in one year, then 2 years, then 3 years. What makes you confident that? I mean, I must admit, when we went into space, I thought it would happen in 5 years. We're now 17 years into it. So, but what makes you confident that you really can do it in 2 or 3 years?
It's a really good question, and we started off by looking around at what technologies were available. We realized that, I mean, for example, oil and gas tools maybe work up to about 175 Celsius, and it's a huge stretch to go from 175 to 225. Some companies have managed to get some stuff to work at 200 Celsius, but that's about the limit unless you use different technologies. And so we realized that we're not going to get there by tweaking things and by trying to get from 175 to 180 and then to 185 and so on. We have to do something completely different. And at first that was a bit daunting. And then we started to do a lot of research. We looked at space. We've spoken to people like JPL, for example, had a number of conversations with them. And we have discovered that there is actually a lot of supply around the world that will give you stuff that works between about 220 and 230 Celsius. We've actually found processors that are fit for downhole use that work up to about 300 Celsius and memory that works up to about 350 Celsius. So many of the building blocks we need are already there. And that, like I said, great tradition of innovation is to pick up stuff that already exists and repurpose it. And that's what we think we can do here. So most of the stuff we need is already existing. There are 1 or 2 areas that are going to be challenging. We're not being naive about that. And in those areas, we see, we might have issues with calibration of sensors, for example. It might be more difficult at high temperatures. There may be issues with 1 or 2 electronic components. And so that gives us the opportunity to be a bit differentiated by understanding what those challenges are likely to be and trying to design around them. And we've already got a number of provisional patent applications in preparation for ways of kind of tweaking the system a little bit to get around some of the limitations that we expect to see, because not everything's going to work perfectly first time. So but we think we know where the challenges are, and we think we've got the plans to address those.
I mean, John, it's an amazing vision. I mean, if you're successful at this, you're basically, delivering the key to connecting to this massive, near infinite energy supply. You'll become, if successful, I imagine you become like a major supplier to, every company basically that's sort of scrambling to take advantage of this opportunity. Do you have, you're a brilliant engineer with a lot of credibility in the space. Are you also someone with the energy to really want to build a massive company? Because I mean, like, do you want success, or isn't that going to be kind of terrifying, the implications of that?
No, we do understand that, and I was talking to my colleagues about it earlier today, and we think that, like you say, there is a potential to become a big, either a big service company or a big supplier, that the same sort of scale as one of the major oil field service companies by leveraging this technology. Because once we have high temperature electronics that works, it's not just for directional drilling. There's a lot of other things we can use it for as well. We can use it for monitoring of wells and for gathering data, and then we can develop software and so on that goes on top of that. But all through my life, I've learned the hard way at first, and I've also taught a lot of the people that, or kind of preached to a lot of the people that have worked with me, about focus. And so we focus on one thing at a time. And so we'd focus on a directional drilling system first, and then we'd be able to build the other things around it. But yeah, absolutely. I think one of our biggest risks is the fact that we might have technology ready before the market is ready, because it's not clear how quickly geothermal is going to grow. But one thing we do know is that it's not going to grow without the enabling technology that it needs. And this is a key piece of enabling technology. So yeah,
have you thought of working with a company like Hyperscience? And I mean, are there any other companies like Hyperscience, for instance, that you would put 1 + 1 would equal 3?
Yeah, we haven't talked to Hyperscience in particular. Conversations so far have been more with the EGS and the AGS players, companies like Sage, Fervo, GreenFire, and I've probably missed a few of them out, but with those companies, we do have 1 or 2 potential technology partners in other aspects of drilling. And we've also got potential partners. I mentioned JPL in the pitch. We've been talking with Lincoln Labs at MIT about their sort of high temperature technology. But yeah, I mean, partnering with people who have complementary technologies makes a huge amount of sense, because it helps us to get to market quicker, and also it helps to enable. You need all of the pieces of the puzzle to be able to enable the development of these wells, and that would help to do so.
Hyperscientists are claiming that they can deliver, drilling for, including at sort of high temperature at great depth for a tenth of the cost of traditional methods. I mean, how worried are you that there's some sort of other technology comes out of the blue like that and sort of changes the game? Or are they in for a harder journey than they may imagine?
It's probably not fair for me to comment on. I didn't see their pitch either, so it's probably not fair for me to comment on. I've done a bit of background, but yeah, I think there's a good chance that conventional technologies will take a chunk of the market. That conventional, like PDC drill bits, companies like NOV are doing wonders drilling granite with those. The things that you wouldn't have thought possible a year ago are now becoming possible. But the opportunity is there for us to work both with conventional and with unconventional ways of drilling the wells.
John, why, if the physics, we've known for a long time that there's this huge energy supply down there. The physics hasn't changed. Why is it that it's only now that people like you are starting to believe there's a real opportunity? Why weren't you thinking this 5 or 10 years ago?
I think, to be honest, because we were distracted by, especially the last 5 or 6 years for the oil and gas business has been very difficult. Since 2014, it's been extremely challenging. And I think a lot of people have been focused on survival and basically exploiting technologies and exploiting business opportunities that they had. What's interesting now is that there's a little bit of a resurgence in oil and gas, and it's quite possible that that's going to take a number of people's eyes off the ball in terms of renewable and alternative energy. They're going to focus back on the business that they know and try and exploit what they've got. But it was really, we were all very busy, and it took me a long time to look at geothermal. I've been looking at hydrogen, and I've blogged about hydrogen a little bit for a while, but I was under the impression until very recently that geothermal was drilling sort of hot, wet rocks in Iceland and New Zealand and places like that, which it still is. But I wasn't aware until maybe a year ago of the work that was being done on sort of EGS and AGS systems. More for me for that. But once I saw that, I realized how you can put oil field technologies and how the oil field technologies that are applied to that can bring the kind of economies and the kind of scale that will bring down the cost of geothermal to an acceptable levelized cost. And I think can enable much faster growth in geothermal than most of the agencies are predicting at the moment.
What percentage do you think of the world's energy will come from geothermal 50 years from now?
We would like to think that, and this is a bit of a pipe dream, but we'd like to think that 2050 it could be getting up into the teens. We're thinking maybe 16%. If it was 16% in 2050, that's a potentially huge market for drilling and sort of completing geothermal wells. It's going to take a lot of effort for it to get there. Most of the current forecasts you see are quite a bit less than that, but I do detect that they're beginning to edge up a little bit.
And so talking to other possible partners and thinking about a whole model here where you're supplying electricity, baseload electricity. What type of pricing do you think, using the technology you're envisioning, what kind of price per kilowatt hour do you think is possible in the next few years?
I think that the companies, what I call the untraditional geothermal companies, are talking about sort of $50, which I think is per megawatt hour. But
yeah, so 5 cents per kilowatt hour.
So 5 cents, which is lower than things like nuclear and coal, and is on a par with natural gas. Has got quite a big range, but it's kind of in that range. It becomes competitive at 5 cents.
Haven't some of these big solar farms got their costs down to 2.5 cents? Am I wrong?
Yeah, I think about solar farms. The great thing about geothermal is it ticks two really key boxes. It has low GHGs, but also it's baseload. It's on 24/7. It has by quite a long way the highest capacity of any of the renewable energies. And for an electrical grid, you have to have baseload power. So I don't think there's anything to touch it in that respect.
Yeah, got it.
And John, just the amazingness of the physics of getting, my mind is boggled by what it takes to build reliable technology, that can work 3 miles below the Earth's surface at the kind of temperatures you're talking about. I mean, if something goes wrong, everything that you need to do to fix that technology also has to be able to operate at that depth and in those temperatures. I mean, how it seems like it's just an impossibly complex sort of physics problem to try and solve to get all that to work. If you can do it, do you have a company with an absolutely massive sort of barriers to entry, as it were?
Yeah, the barriers, I mean, there's more than just temperature. There's also shock and vibration. You get a tremendous amount of vibration drilling wells, and it's going to be worse in the kind of hard formations that you could be drilling for geothermal. So first of all, you need to have the experience of doing, like, 25 years experience of how to make things work in that kind of environment, absent the temperature. But additional to that, we think part of our sort of barrier to entry is going to be the experience and the fact that if you try and do it from scratch, not knowing anything about how to do it, it's going to take you 10 years to learn. And also the fact that we think that there is some IP that we can place around some of the activities we'll be doing.
How much have you spent so far on it, and how much more will you need to spend to get it completed?
It's very early stage. We've been kind of giving of our time freely so far. We think to get to our prototype in 18 months, it's going to require about $5.5 million. That, if you like, that seed, and then to get to a business at scale with additional, developing the steering head and also the working capital we need to get the business up and running and build a fleet of tools for rental or build tools for sale. It's probably about another 12 million, which would be a mixture of equity and debt. But we think we'll generate cash fairly quickly once it's working. So hopefully a chunk of that could be debt, which we could pay back within the first 5 years.
Well, thank you so much. It's absolutely fascinating, and obviously, on behalf of the world and all of everybody in the world, we wish you all the best with it. So,
yeah, and thanks, guys. Great to meet you.
Thank you.
Great to meet you, John.
Thanks a lot.
GreenFire Energy is developing and implementing a closed-loop geothermal technology to produce vast geothermal resources where conventional geothermal just can't. And we produce power and from industrial applications such as hydrogen production. You're looking at our demonstration project completed in 2019 at Coso, California. And right here, if you can see my cursor, is the surface portion of the closed loop system. What does it look like downbore? Well, we inserted vacuum insulated tubing and a downbore heat exchanger and to a well that wasn't producing at all, couldn't be used, and we were able to show we could produce over 1 megawatt of power. We circulated water and supercritical CO2 in this resource. And so we essentially retrofit an existing well. Retrofits are a great business for us because hey, the wells are already drilled. Everything's there. Everything's understood about the well. The resource is well understood. Contracts, permits, everything's in place, even surface systems. So this is a great business because it's low capital expenditure, it's low risk, and you can get a quick return on investment. But does it scale? Well, this is an underground mountain of heat at COSO that we're very familiar with. And we, using our technology and only existing drilling technologies, we could turn that 130 megawatt operation into 2 gigawatts. We have the most scalable geothermal technology because we're operating over a much broader spectrum compared to conventional geothermal in terms of temperature, permeability, water resources, and pressure. So, for example, this allows us to do the retrofits of both geothermal wells and some oil and gas wells too. Most importantly, we can drill new wells to expand production from existing geothermal resources across this vast middle range of permeability, which is huge. And then, of course, we can go into hot, dry rocks. These would be large greenfield projects. And we have the capability of doing this. We've done it in the past. And we have the intellectual property that operates over this entire spectrum of geothermal resources. We have a land and expand strategy, which means we're talking to lots of geothermal companies. We're already very involved with 8 of the top 10. Obviously, they have superior sites. They're already doing geothermal. All the items I discussed with respect to retrofits are already in place, the infrastructure permits, everything. And with our technology and our patent position, we can develop projects and cut years, not months, years off the traditional geothermal project development timeline. We have a commercial pipeline, and we have a commercial pipeline of projects. We have 2 that are being completed in September, retrofits, and we have 20 in development. You can see on this map where they are across the globe. But we need help. We need to have additional staff to meet these opportunities. And so we're raising a Series A investment round, and we're seeking applications from oil and gas folks who want to, shall I use the word pivot to geothermal? And this is a $15 million round, and it's on the same terms as for the strategic investors that have already circled the opportunity. So I'm ready for questions and answers.
Sorry, I'm scribbling as you're talking.
I can go first. I'll go first, Richard, on with which is help us just understand the core of your technology better that the company is based on. As a closed loop well, are you talking about basically a pipe within a pipe, that you take a well and it's a pipe within a pipe that is used to create this fluid circulating? Or is it something, is it not always that? Is it, oh, okay, there, it's a loop like that.
Yeah, no, that's a good question. And when you talk about closed loop, the closed loop can be in various configurations. And it's really fun to sit at a whiteboard and come up with new configurations. We've done a lot of that. But the 2 basic ones are, as I showed you on our retrofit demonstration project, the coaxial downbore heat exchanger approach, or using a U-loop. And the distinctions are not as great as you might expect in terms of power production, but of course the technology to drill these wells and complete them in very hot resources is rather different. So initially, we're looking at most of our projects in a coaxial downbore approach rather than a U-loop approach, but we look forward to and have worked with strategic partners and are still looking at the U-loop opportunity because it does have great potential.
What temperature do you have to reach at the bottom there in order to create a power supply that is efficient, that actually works? Does it need to get to 200 degrees type temperature that we've heard from others, or can it be less than that?
Well, it depends. Well, as you might expect, it depends. And we've spent 7 years modeling different resources. So you might think of GreenFire as a tailoring company rather than just a closed loop company, because we look at various resources, we get the information on those, and then we tailor our closed loop solution to those resources. So, so we can often tailor a solution to the resource at a variety of temperatures, but at a variety of depths and a variety of costs. All those things are closely related, as you would expect. So for an example is at the largest geothermal location in the world here in Northern California, they have a steam dominated system. And steam dominated is a little bit the opposite in terms of what we tailored for them, because on the retrofit I showed you at COSA, we were co-producing brine up the side of the well in the annulus. Here, we're attracting steam from the resource, so it goes back down into the resource. So it's really two closed loops. We're extracting only heat from the resource, not water mass. And this is a huge thing because most geothermal resources degrade over time. And if you can keep water in the resource and pressure, then by producing the resource, you're not, as with conventional, robbing from Peter to pay Paul, pulling water out of the resource. And in fact, what our plan is on this particular project is to restore the resource to the biggest production location in the world, because you can then recharge the resource with the water and pressure that it lost over the years.
If there was one other of the 4 companies in this competition, one other of the 3 that said they'd come and work with you for nothing, which one of those 3 would you choose?
Of the other 3, we were actually in the Game Changer program with Hyper Sciences. And there's an obvious, but any technology that makes it cheaper and more efficient to drill, we're totally in favor of. They're all going to help us. We want them all to be successful. And so you should invest in all of them, right? Hyper Sciences. But
anyway, you working together with something like Hyper Sciences could be very exciting for you in the future.
Exactly. And I've presented with Mark Russell before as well, because the technologies kind of naturally go together, but also in terms of high temperature drilling equipment, that is very important as well, particularly when we go back to these hot, dry rock locations that I showed here, I think. Yeah, when you're going down into the plastic zone, and this is going below fractured zone, you're getting into this location. This is very hot. It's very productive from a geothermal point of view, but it also has challenges in terms of how you connect these wells. And some of those are why we often simply work in the coaxial approach with a single vertical well.
I'm trying to understand what your core competitive advantage is. Like you described yourself as a tailoring company, which implies that really the key expertise here is that you can model a wide variety of geothermal situations differently and pick the right technology to fit any given geologic condition. Is that the key advantage, that your modeling skills?
That's the key advantage. And we picked up a bunch of patents along the way. And it's no accident that we have this very strong closed loop patent position, because when we look at individual resources, none of them are exactly alike. So we have variations on this basic closed loop technology that fit them. So for example, I mentioned that we can also use this technology to pump oil and gas wells. And this is an example of using that closed loop to create a thermosiphon from energy in the geothermal resource, coupling it with a magnetic pump to actually produce oil and gas. And why would you do that? Well, the energy industry and the oil and gas industry wants to be more green. We should let them be more green and save them money at the same time. Because if you're producing electricity, say in an off-grid location, you don't need to pay a lot of money for electricity to power electronic submersible pumps or line shaft pumps in an oil and gas well. A really fun one in terms of tailoring is the hot springs world. As you can imagine, hot springs are fabulous geothermal locations, but particularly in Japan, where hot springs are very common, they don't like geothermal. The reason is they're afraid that with a conventional geothermal system, it's going to interfere with the hot spring. And with our system, it's closed loop. So we can go down, grab the heat only and not interfere with the hot springs. And so there's a bunch of modeling we did for one of our Japanese customers at a place called Obama Onsen, which you can guess who might have been there. So that's an example of tailoring as well. Tailoring also with hydrogen. I mentioned that earlier, but we were asked by the largest hydrogen producer in the world if we could use geothermal energy to make hydrogen more efficiently. And we looked at it, and yes, we can. There are lots of different hydrogen production techniques, and we looked at these, water splitting and thermochemical methods, and determined that the heat from the resource could be used to make it more efficient. And really for two basic reasons. If this is the amount of energy that's required and you're picking up an increasing amount of energy from heat in the resource, the amount of electricity you need for an electrolysis transaction goes down. And then you don't need to compress as much of the hydrogen on the surface because we are making that hydrogen downbore already at pressure. So what this has resulted in is giving us a great intellectual property position, because we've been at this for 7 years, but every time we run into a new resource and new tailoring, not every time, many times, we will run into another patentable idea. And in fact, it's been both a shield and a sword for us, because one of our customers in Japan heard about closed loop geothermal and actually called us and said, "You have the patent in Japan. We should work with you." And that's one of the projects we're delivering in September.
But Joseph, for some investors, their motivation is going to be they really want to make a difference to the planet. And too much talk of patents almost sounds like, it sounds defensive rather than what you can actually go out and do. Talk about, like, you're trying to raise the Series A. What is there a focused purpose that it is for?
Well, it's to the Series A is to build our staff, as I said, and we're looking at really all of that full range of project opportunities that I had earlier, right? And this is a huge opportunity, hot, dry rock, but also this middle range of permeability too. And if let's say you were to look at this just from a climate change point of view, and we actually won an award at the Renewable Energy Conference on the basis of working for emerging economies, on the theory that emerging economies they are going to be getting a lot of energy. They have to have a lot of energy power to develop, and they will have that. Do we want them to have coal, or do we want them to have a natural resource such as geothermal? And so Indonesia and the Philippines are great. And one of our projects that we're delivering on in September is in the Philippines. And we're already in this land and expand process with a couple of companies in the Philippines. So are they going to develop a natural resource or not? So if we can expand the range over which various countries have their principal source of energy being a natural resource, that's a big deal in terms of climate change.
The two wells that you're already drilling, how much energy are you getting out of those 2 wells?
This one was back to the retrofit. We calculated over a megawatt, 1.2 megawatts, but that's just on an individual well. Are you already getting it, or you're hoping to get it? We got that much, but that is not a continuing project.
Okay.
Instead, that and others turn into groups of retrofits because they're more efficient. What you put on the surface also helps here, because doing all of this for one well is not as efficient economically as doing it for a group of wells or an entirely new resource. So I'm not sure I answered your question, Richard.
No, that's fine. It's horrible when you were told us 30 seconds ago. But anyway, look, thank you so much. It's fascinating what you're doing. And
good.
Really hats off to you. Incredible.
Thank you very much.
Thanks much, Joseph. Good luck.
Appreciate it. Thank you. Take care.
Thank you.
Hi, I'm Atta Aradottir, CEO of Carbfix, and you can call me Ara for short. Carbfix turns captured CO2 into stone underground in less than 2 years through a proprietary technology that imitates and accelerates a process that nature has applied over millions of years. This piece of rock sample consists of basalt. It's one of the most common rock types on Earth, and embedded in the pores and fractures of the gray basalt, you see white crystals. And these are carbonate minerals that contain solidified CO2, which we've captured from geothermal emissions. The Carbfix technology was within the geothermal sector, and our flagship project is located at the Hellisheiði geothermal power plant, a hydrothermal flash steam plant from which we've captured and injected over 100,000 tons of CO2 and H2S of volcanic origin to date. We capture the gases by taking the emissions through a water scrubbing tower where CO2 and H2S dissolve in water. And this is then injected into nearby basaltic formations for permanent mineral storage. We currently operate this process at about $25 per ton, which is very cost competitive. We also inject CO2 removed directly from the atmosphere through our collaboration with the Swiss company Climeworks. Their direct air capture units require considerable heat, making geothermal the ideal energy source for such operations. Here we have some photos of part of the Carbfix team and some of the infrastructure we've built for CO2 capture and injection at our main site here in Hellisheiði, Iceland. And it's through this natural mineralization process that the CO2 turns rapidly to stone underground. No added chemicals are needed for the process, just basalt, CO2, and water. Carbfix allows for fully eliminating CO2 emissions from the geothermal sector, which currently exceed 10 million tons per year globally. Systematic application of Carbfix and direct air capture processes next to geothermal power plants further allows geothermal energy to become the first carbon net negative energy source of the world. And our goal is to bring the Carbfix technology to the gigaton scale, and we are already working on new projects in several countries. New geothermal projects are, for example, under development in Turkey and Italy, but we're also developing projects beyond the geothermal sector because it doesn't matter where the CO2 comes from. Basalts will rapidly and permanently turn into stone through the rock-solid Carbfix process. And thanks so much from all of us here at Carbfix, and I'm happy to answer any questions that you have.
Chris, you first.
So Edda, first of all, I mean, it's amazing technology. Help us understand just a bit more clearly the link with geothermal. The CO2 that is being emitted by geothermal that you're talking about is traditional, shallow geothermal technology, correct? It's not like the whole pitch of geothermal is that it's carbon zero. And so some people will be a little puzzled to hear about the CO2. So that you're not talking about the new sort of hot rock deep geothermal projects. You're talking about existing projects that have surface water that contains CO2, and that was the initial problem that you were looking to solve. Is that right?
Yes, that's correct. So we are working from hydrothermal flash steam plants, which have been in operation for decades, and they are typically built in volcanic regions where we already have very hot rock and hot fluids that we bring up to the surface. They're a mixture of steam and geothermal water, and with the steam phase, which drives turbines generating electricity, come geothermal gases, and their CO2 is the most abundant geothermal gases. Of course, these types of power plants, they emit much less CO2 than comparable fossil fuel burning power plants of the same size. But nevertheless, this can be a considerable emission depending on what type of geology the geothermal plants are located in.
Right. But the broader fit with geothermal that you're talking about is that geothermal plants are a natural energy source for your carbon capture process, so that you can basically pair it with carbon capture from the air directly, and then store the carbon. Yes. And is that because it's fundamentally a heat-driven process? It's more efficient to do it directly from heat rather than via electricity?
Yes, you use some electricity, but mainly the process runs on heat. And just to emphasize that the carbon capture technology that removes the CO2 directly from the atmosphere, that's not ours. Ours is what comes after, injecting it into the subsurface for permanent mineral transformation. But of course, our technology is required so that we're able to permanently remove what we've already emitted.
Can you turn the rocks into anything that could be used for anything else?
You can fight climate change through these rocks. Right. The processes and the mineralization trapping, it happens a few hundred meters underground. And we would want it to stay there. So okay. The main purpose is to permanently get rid of the CO2. We do it efficiently, cost effectively by making the processes happen underground. There are some other companies that are working on doing this in reactors on the surface, which is then of course requires more energy and is more costly, but then you might be able to use the stones for something, but that's not our purpose. It's just to get permanently rid of the CO2. Eliminate it from the picture completely.
How do you get paid for this? Because if it costs $25 a ton, who's paying you to do this?
It's the emitters, and as I mentioned, we're also looking beyond the geothermal sector. The technology is born within the geothermal sector, but it doesn't matter where the CO2 comes from. So we're already developing projects in waste management. We are in discussion with cement producers that they might be able to use the technology for reducing their emissions, and some of the harder to abate sectors, like some of the metal producing processes. We're also exploring the feasibility of applying our technology to capture emissions that can't be abated in other ways.
And help us figure out how this could play long term into a sort of scaled up carbon capture economy. People talk of this magic number of $100 a ton, that if we could get overall carbon capture below $100 a ton all in, that that the planet could afford to really scale that up. If your piece of it costs $25 a ton, how can you see like a model where you would partner with someone where you could get that overall process down below $100 a ton, or is that's just years and years away still?
Well, it's a mix. I mean, we're on the one hand we have to recapture what we have already emitted, but on the other hand we have to stop emissions, and that's really where our technology mainly comes into play to bring it to scale in the next coming years and decades. And I actually have a slide that sort of put this into the broad perspective. When it comes to fighting climate change and meeting the goals of the Paris Agreement, we have to reduce our emissions by 1,000 gigatons or somewhere around that until 2060. And without carbon capture and storage, we will never reach that goal. So we have to apply carbon capture and storage in the harder to abate sectors. And on top of that, we have to also recapture some of the emissions that we've already put into the atmosphere. We're already at 420 ppm, and that's way too much CO2 in the atmosphere. So we have to bring both types of processes to scale, and our technology can work with both, stopping emissions and also retrieving some of our previous emissions.
So could a coal power station be a natural customer? I mean, is it anyone who can scrub CO2 from their waste stream and supply it, that they're a potential partner for you?
Yes, absolutely. But of course, we have to transition away from burning fossil fuel. So in the more developed countries and more developed markets, of course, we would expect that these markets are already transitioning to renewable energy, whether it's geothermal, wind, or solar, or hydro. But in the less developed countries, we know that coal-fired power plants will continue operations for quite some time, and then our technology can absolutely come in and capture those emissions and permanently transform it to stone. But we're also rather thinking beyond sort of the power plant sector. It's also all the other industrial sectors where we're producing some of the raw materials that we need for the energy transition, like silica, and some of the metals, aluminum, and so on, and of course, cement and steel.
Well, what other carbon capture firms are you impressed with in the world?
Excuse me, could you repeat that?
Well, which other carbon capture firms are you impressed with in the world? Which
there are several carbon capture companies out there. Of course, some of them are focusing on stopping emissions from the industry. Others are reclaiming and recapturing our emissions. We've been working with Climeworks for quite some time now. Excellent collaboration, and it's made some of the first of a kind project come through here in Iceland, which we will start operations in later this year, where we will bring these two technologies to scale. Carbon Engineering, of course, is another very interesting company, and also recapturing CO2 from the atmosphere. When it comes to capturing emissions directly from the source, the power plants or the industrial production facilities, then Aker Carbon Capture is an interesting company from Norway. And there are many companies out there bringing these types of technologies to scale, which is what we need.
And what do you need financially to keep the company up and running?
Of course, we need funds, and it's both to make new projects come true, and we will be starting a project financing round in the coming months for a big project, which will be a first of a kind project here in Iceland, where the plan is actually to build a hub that will receive CO2 from various parts of Europe, and we will bring our technology to the megaton scale and be able to inject about 3 million tons per year in the coming years. So we need, of course, funds for that. It's also important that we continue developing our technology. We've proven it under specific conditions now, but we know that we can take it even further. We use water for dissolving the CO2 when we inject it into the subsurface. And a very important further innovation that we're working on is to demonstrate the feasibility of using seawater rather than fresh water, because of course we know that fresh water is scarce in many parts of the world, and this is a project that we will be doing in the next few months. Another important aspect is to demonstrate the feasibility of mineral storage in not just basalts but other types of rock formations. So we are working on, of course, getting new projects up and running in different sectors, of course, within and beyond the geothermal sector, and continue innovation.
So what's the dream, Edda? Like how do you picture, in your dream, where do you picture yourself in 10 years' time, and what kind of scale company do you believe the world needs you to build?
Well, we have to bring a technology like ours to the gigaton scale. So within 10 years, I hope we will have that goal, not the too distant future. So this is what we're working on. Of course, this is a huge task, but we have a roadmap, and my vision is that we can stick to the roadmap. Of course, we need various things, financing, of course, among others, but also sort of bring down regulatory barriers and so on, because unfortunately, the regulatory frameworks in many parts of the world does not support some of the, or maybe isn't enough supportive of some of the excellent new climate technologies that we have already existing and need to bring to scale.
Well, thank you very much, Edda. Very, very exciting project. And Chris, we're going to have to go to Iceland and check it out sometime.
Please be in touch. When you're here, we will be happy to show you around.
Lovely. Well, thank you so much for your time.
Thank you.
Thank you.
Awesome. Okay, so thank you, startups. Those were awesome presentations. The judges are off deliberating, so they will come back in a moment to give some feedback and have a chat with me about what they heard and what they think of the startups and the risks they face and the opportunities. In the meantime, I'm going to show a highlight reel of the semifinal round for the Pivot 2021 New Venture Competition. So you'll get to see all 10 companies who competed and a little bit more about them. And the 4 finalists, of course, are in there as well. And take a look at the end of the video. You'll see the Audience Choice Award poll pop up. So vote for your favorite startup, and I'll announce the winner of that as well after the judges' feedback. So we'll be back in just a second to talk with the judges. Okay, all right, judges. So we saw all the startups. So now we're going to get some feedback from you and some thoughts about what you saw today in the pitches. So let's start. We'll just go in order of the order you saw them. So let's talk about hypersciences. What are your thoughts?
I think both Chris and I are virgins to this, which I suspect makes it quite interesting. We're just looking at this world with fresh faces. I found them incredibly exciting. I mean, first of all, the person who runs the company used to compete with us in space, so a lot of respect for him. And if you can drill at the speed that he's attempting to, and break rocks at that kind of speed, geothermal could be, could suddenly become very, very real and very, very exciting going forward. Tremendous what they've achieved, and obviously he pointed out that the Earth is effectively a giant nuclear plant. So if you can get to that nuclear energy, or you get to that heat, we can maybe power 12% of the world by 2050, which will go a long way to dealing with the climate change problem.
Chris?
Yeah, my first reaction to him was, this is crazy. Like the thought that you can drill safely and in a controlled way and in a cost-effective way by firing a freaking bullet at Mach 5 into it. Like, it just seems so unlikely. It seems really, really unlikely. It's like, how could that possibly work? And especially, how could it work like deep underground? So you have to look, like if I was an investor doing it, I would definitely want to do some more due diligence and really see how it is. So I get the, it works on the surface, that you clearly, if you throw something that fast at a hard surface, you're gonna penetrate. It's gonna be dramatic. But can it really be controlled, in a well environment? And the thing where I got a little bit skeptical almost was he was talking like some of the plans I've seen involve quite narrow bore drilling, which is more cost effective. For his technology to work effectively, it seems like you have to have a wider sort of track being drilled in there. So I don't know. I mean, it's down to the numbers. But man, if the physics really works and they can demonstrate it both in shallow wells, but also deeper as it starts to get hotter, I mean, it's incredibly exciting. And I love the fact that two of the companies are absolutely strategic technologies. I mean, if it's, you know, what is the cost-effective path to reach the nuclear reactor? That's the question. If they can provide that, they change the world. You know, they change the world. And so an investor who wants to change the world, I mean, it's going to be a zero or it's going to be huge.
Right.
A company like that.
Exponential.
Yeah. And I think that applies to most of these companies, but the amount of money they need is relatively small compared to, and it's incredible that they should even have to be struggling, I think, to get sort of $10 or $20 million. I mean, if each one of them had the 20 million, one of the five could easily work. But
sure.
Anyway.
It's the story of geothermal, under-recognized, underfunded, largely incremental, gigantic prize. So it is across the board, that story with every startup, and even R&D for geothermal. Okay, so how about Hefe, John Clegg?
Same strategic role, right? Like they, if successful, this is an alternative route to unlocking the nuclear reactor down there and bringing up an unlimited amount of heat energy. So what I loved about him was that sort of experienced engineer, measured approach. There was a sort of humility about him. There was a, he did not sound hypey. Hefe did not, it sounded very measured and given the credibility and the track record of invention that's already happened there, I mean, I think it's it's a really exciting opportunity. It seems like, he was putting quite a long timeline on when you really get to the point where it gets interesting. And I guess there's some risk to him if it turns out that there are routes to scaling up geothermal energy that don't need to go quite that deep or at that high temperature. But I was like, to me, it's incredibly exciting to have one of the lead inventors and engineers who has helped pioneer high temperature drilling in the oil and gas industry to be pivoting to geothermal. I mean, that's amazing. That is a metaphor for the whole thing that's happening here. Indeed. Of an industry reapplying its same skills to kind of get energy that isn't going to destroy the planet. So I was excited by him, and like if I had to like just bet right now based on what we saw so far between them and Hypersciences, I would go with him, even though it's more sort of incremental and less flashy, but it felt to me very much like the real deal.
Yeah, I think he's obviously more tried and tested, and Hypersciences is more out there. Anyway, so far I think both of them should be supported because they've it's just impossible for us to say which one's going to.
Yep. And you got to make the big bets too, the incremental bets and also the high risk bets, right?
But I mean, I'm sure that with his experience, he'll run a successful business. I mean, he knows the ins and outs of it.
Yeah, that humility you're hearing is likely due to having been in the trenches, right? So he's been through product development his whole career, so he's got that grounding. It's great. Okay, so how about GreenFire? Thoughts?
I mean, I like the fact that they're using wells that already exist to go down. I mean, there's a lot of it sounds like a lot of logic in that, and I also like the fact that he wasn't adverse to working with somebody like Hypersciences and partnering up. I think that there must be some of the, 2 or 3 of these companies that if they put their technologies together, either 1 + 1 would equal 3, or 1 + 1 + 1 would equal 5, and so people, shouldn't necessarily be proud and just feel, that they should do their own thing. This is a difficult sector. There's massive upside to anybody that can break through, and it's sometimes better to have 1% of something than to have 100% of nothing. So, but anyway, I like the fact, and I also like the fact that they said, when we asked where geothermal could be in 2050, instead of saying 50% of the world's energy, it was something like 12%, and which sounded much more realistic, and would be wonderful if it turned out to be the case.
Mm-hmm.
Yeah, I'm not sure the format of this competition, if that's what it is, did him any favors, because it's quite a complicated company and a more complicated story to tell. And so occasionally I felt the story, at least to virgin investors in the space, it lacked focus compared with the others. It was like, we're great at this, and we're also great at this, and by the way, we're also doing this, and then there's this other thing that we're doing in Indonesia that could really have promise. And like it made it to invest early on in a company, you want a real sense of focus, and we are uniquely good at this thing. We can kill at this. We're amazing at this. We're better at anyone else in the world, and we're going to do this, and here's why this one thing matters. And there were just a lot of different things that we heard, which made it harder for me in the time we had to get excited. I think the path to get excited about that company probably involves a deeper dive into the different things they're doing and really understanding how the patents help and so forth. I as I said in my comments to him, I get worried when people focus too much on patents, because it's any business where your moat is your lawyers. That doesn't excite me. I want people's moat to be their innovation, their energy, their lead on a specific area that they can do uniquely well. And so I like as happens with many TED Talks that we have, I would say to him, if he was presenting again, say a bit less and go in deeper on it and make a couple of points land. And that might be a more powerful way to go. But having said that, I have no doubt the company is exciting. All of the things he's talking about seem to be a key part of the geothermal mix. And so I just don't think this particular format allowed it to shine as well as it might.
Very time constrained, yes. Last but not least, Carbfix.
Shall I? I'll hit off on that. About 20 years ago, my wife, we were talking about climate change, and she's a down-to-earth Glaswegian lass, and she just turned to me and said, there must be somebody out there in the world who could come up with a way of extracting carbon out of the Earth's atmosphere. And it got me thinking, and we set up a $25 million prize to see if any company out there could get the equivalent of Europe's carbon output out of the Earth's atmosphere. And a lot of companies entered into it, but nobody got close to a way of actually sorting out the problem of climate change by extracting from the atmosphere. But this company, in a small way, but has come up with a fantastic project of trying to make geothermal completely carbon neutral by taking the carbon aspect out of it and turning it into rock and putting it back into the Earth's surface. And I think government, I mean, whether it's a business or not, I think most likely depends on governments and how urgently they want to fix the problem. But If they want to fix the problem at $25 a ton, it sounds like, you know, a good investment for governments to make. Or so exciting project, a great project.
What do you think, Chris?
Yeah, it's obviously it's very different from the others in that it's not really I don't think directly about amplifying geothermal. It's a more generalized solution to the climate issue we face. So right now, today, there's just a massive difference in the economics between, you know, what it would cost to extract carbon from the atmosphere and sequester it permanently versus what it would cost to avoid emitting it in the first place. And so people with dollars to spend, whether it's a government or a philanthropist or an investor, like it feels like you can do a lot more today in other areas of just avoiding, you know, sequestration in the first place, or indeed investing in something like geothermal. So I worry about whether direct carbon capture will ever become super cost effective. It does take a lot of energy to pull in the carbon, and unless you have a natural source, you know, her first project there worked because there was this natural source. Someone else had already paid to, you know, trap the CO2, and it was a disposal project, and there was funding to do that. So that's my question: is how well does that scale? I actually to me, the logical next step is to work with people who are seen as part of the problem. Some of the people like, you know, some of the existing coal power stations. I mean, it's probably more cost effective for a government to require their coal power stations to clean up their act and pay to trap the CO2 and, you know, have it sequestered, than to knock it all down and build brand new energy systems. So there may well be opportunities like that could give a company like hers huge opportunity, but it's difficult. I think to build it, you kind of have to dance with the devil a bit, and or have very, very patient investors who will wait quite a long time for the truly big scale up. But she was very impressive, and like you would want to find a way to invest in the company. She seemed like she could really get things done. She has got things done, and so I like it. I just worry about the fundamental physics there and the fundamental economics, whether it does compete with other ways of limiting carbon.
Understood. Well, look, I want to tell you all, thank you so much for looking at this, for showing up, and for engaging. Geothermal is this gigantic sleeping giant resource that nobody cares about and nobody is looking at. And it takes engagement from people like you. And if this even word that you were judging this competition bounced all over the oil and gas industry. And there were so many people that were excited and surprised, and in the geothermal industry as well, that anybody cared. And that's really what starts the ball rolling down the hill in terms of helping tease out new innovation and helping new startups get excited to try. So thank y'all for coming and spending your time. I know it's really valuable, and you both rock. Thank you.
Jamie, you're a force of nature.
My geothermal pun.
You're a force of nature. Thank you. Thank you so much, Richard, for doing this. It's really great to see you.
Thanks, both of you. See you soon.
Okay, wow, that was a lot of fun. I hope you guys enjoyed that. I really did. I have the results of the Audience Choice Award that I'm going to share with you. But first, I want to thank everybody that participated in the competition this year. We put the startups through a really high pressure, really fast turnaround, semifinal and final round here. And they were all just absolute pros. So congratulations to all four, quite frankly, all 10 startups that participated this year. Awesome. Many, many thanks to Sir Richard Branson and Chris Anderson for lending their brains and their voices and their time to geothermal. Awesome. Thank you. You guys are amazing. Okay, so what we did, we ran the poll before the judges gave their comments. So it will be interesting to see how the audience fared and how in line the comments were judges versus audience. So without further ado, and I wish I had a drum roll here, but it was pretty close. We had two startups nearly tied and everybody was pretty neck and neck, but at 38% of the audience votes, GreenFire won the Audience Choice Award this year. So congratulations to GreenFire and Joe. Congratulations to all of the startups for making it into the finals. And I hope that you all's ventures flourish over this next year. Okay, so we are off. If you're planning on, if you're even thinking about doing a startup, do it now. Do it now. Now is the time. There is so much venture capital coming into the space. You'll see it later today in another panel, the venture capital panel. Tune into that. A really fast growing trend of venture capitalists and private equity looking for geothermal investments. So if you're even thinking about doing this, now is the time to do it. Jump. All right, y'all. Thanks for coming to the Pivot 2021 New Venture Competition, and we will see you at the next session. Bye.